Organized by Department of Chemistry, Shri Vaishnav Institute of Science, Shri Vaishnav Vidyapit Vishwavidyalaya, Indore. I, Dr. Asmita Sharma, on behalf of Department of Chemistry, welcomes to all. Your active participation is important throughout the session. You can enter your questions and comments in the question box throughout the presentation. I will bring them up during presentation, and we will also have time for question at the end. I welcome Dr. K. Venkatachalam.
Yes,
I invite Dr. K. Venkatachalam to deliver his talk on UV spectroscopy and sample analysis by classical methods. Over to you, sir.
Okay, madam. Thank you. So today I will take UV spectrophotometry and classical methods, how complex complex samples analysis, and then before I will take just reference for all faculty members, because directly we are taking the subjects little boring, so just reference for simple chemistry, then I will take for my subjects. All faculty members take paper and pen. That is very important. All faculty members, because some ready, dear faculty members, all are ready to
Yes,
take paper and pen.
Yes. Yes.
Yes, yes. Okay, madam. So my slide is sharing. No,
sir.
Oh, okay, okay. Wait, madam. Okay, madam. So, dear faculty members, I want this three compound is there. I want what is the IUPAC name? The three compound. The 1, 2, 3. The first compound, what is the name? The second and the third. So what is the IUPAC name? I want the IUPAC name. These three compounds.
Professor, excuse me. The third one, COOH group, Professor. COOH group or the last?
Wait. CHO, aldehyde.
Aldehyde. Okay, Professor.
So faculty members all are ready?
Yes, Professor.
So here's the answers. So what is the first compound name?
3-chloro-1-propene, Professor.
3-chloro-1-propene. Okay. You explain, sir. No problem. Second.
2-propene-1-ol, Professor. Or prop-1-3-ol.
No. Any one you take.
Yes, Professor. 2-propene-1-ol, Professor.
2-propene?
1-ol.
Okay. Third.
Propan 2 on 1L. Propan 2 on 1L.
No, that is any others? Okay, good for two. First two is correct, no problem. Any others? Faculty members?
Two functional groups are there, no? So what we should
Polyfunctional group is present.
Yeah.
All the compound is polyfunctional
Yeah.
presence.
Third one, what we should
Yeah, I will explain.
give
Madam.
the priority.
Any idea for other faculties? Yeah, definitely I will explain. What are any other faculty members? So here, among the three compounds, they are present for two functional groups. The first compound, halogen also presents and double bond also presents. And the second compound, alcohol OH is present and double bond also present. The third compound, ketone also present, so aldehyde also present. So this time, so when come the polyfunctional groups, the time what we can do, simply I explain one method. You follow that method. That is very important. That is you can use very easily to explain. So what is the method? Keep in your minds. So what is this? Canal comb. So this is what is a canal comb used for canal comb, and then square bracket, double bond, triple bond, then all others. So canal comb, what is the canal comb? Double bond, triple bond, then all other. C, the first preference giving for carboxylic acids. That is for C. Slide is visible? Slide visible?
Yes,
Madam?
yes, sir.
Yes, sir.
Yes, sir.
So then for A for acid derivatives. Then for N, nitriles, that is for C triple bond in nitriles. And Al, that is for aldehydes. And K for ketones. And A for alcohols. And Am, that is for amines. Db, that is for double bond, and then for triple bond, then all other chloro, bromo, nitro, alkoxy, and the phenyl groups. So that is for final. So this is the preference. We are giving the preference first for acid groups. Then acid and acid derivative middle, the sulfonic acid is present in the middle. They are giving. So this is very important for canal comb. So in case the two functional group is present, so the now what this is the preference of first acids, then acid derivatives, nitriles, and aldehyde, ketone, alcohols, amines, double bond, triple bond, then all of this. So this is the rules, the polarity natures, and then rules. So now you can see here CH2 double bond CH2 Cl. So two functional group is present. One is the double bond, another one is chlorine. So now you can see double bond is here. The chlorine is last presence. Double bond is first present. Then for chlorine. So we can preference first for double bonds. So the double bond nearest carbon is first carbon. So this is for second carbon. This is for third carbon. So 3-chloropropene is the correct one. So canal comb, this is the very important. You can use this. Next, CH2 double bond CH2OH. So this is for, so you can see alcohol is present, double bond is present. So in our rules, so alcohol is front. So alcohol, where is alcohol is present? So A. Here alcohol is present. Where is double bond? The double bond is present here. So first preference we are giving for alcohols. So alcohol nearest to carbon is first carbon, then this is for the second carbons. So from 2 in 1 all. So this is for the second compounds. And the third compound, ketone and aldehyde is present. Ketone aldehyde is present. Already I told where is the ketone and the aldehydes. So this is ketone is the aldehyde is first, then for ketone. So in our rules, the aldehyde is first, then for ketones. So we give first preference for aldehyde, then for ketones. So now we can calculate 2 keto propanol is correct, or 2 oxopropanol also correct. Aldehyde means Al, OH means OL. So aldehyde Al. So 2 keto propanol or 2 oxopropanol is the correct answers. So we are taking for in case the polyfunctional group is present, we can use these rules for canal comb. So this is the points. Any doubts, dear faculty members? Any doubts?
Can this new update guidelines? It's for IUPAC.
Yeah.
It is a new guidelines for IUPAC nomenclature.
Yeah. This is for IUPAC nomenclature. Yeah.
Because when we discuss about the IUPAC nomenclature, then we have priority to unsaturated bond first.
No.
The first is okay, but now second case, that is
that is double bond, triple bond is present. That time you can see consider. But in case you present this, so this is the correct rules. This is the correct rules. You can check. You can check your books, all textbooks. This is the correct answers. Okay. You can check your organic books or any books. You can check. So this is the correct answers. So double bond is not in halogen is present. The double bond is not. The double bond is the first carbon, and the alcohol double bond is present. We are giving for alcohol is the first carbons. So you can see the organic books. Okay. Any doubts?
No, sir.
No, sir.
No, sir. Clear. Professor.
You can see the organic books.
Yes, Professor. Yes, Professor. I remember. Then pyruvic acid, we can say 2-oxopropanoic acid. Pyruvic acid.
Pyruvic acids, what is the formula? I don't know.
CH3, C double bond O, COOH.
Yeah. Acid give first.
Acid gives first preference.
Yeah. Acid give for the first.
Thank you, Professor. Thank you.
Pyruvic acid means common name.
Yes, Professor.
That is for IUPAC. That is not for IUPAC name.
Yes, ma'am.
Pyruvic acid.
So okay, and next, so many compound is there. First compound name, directly tell first thing, we will go for our syllabus. So what is the IUPAC name, the first compound? No need to paper, directly you can say.
Pentane.
1-amino pentane.
Yeah.
Pentane amine.
One
Pentane
amino
amine.
pentane, madam. Amino.
Pentanamine it is.
Pentyl amine means that is common name. Pentyl amine, that is common name.
Pentyl.
Amino. One amino pentane is the correct answer. Amino pentane. So next, for second. Second compound, what is the functional group is present? In
Ether.
Ether, yes. Ether is present. That's why we can call for oxy.
Butoxybutane.
Methoxy, correct. Next.
Cyclopentanone.
No, madam. Second compound.
Second. Okay.
Here, slide is visible.
Yes.
Yes, sir. Slide is visible.
Yeah, 1 methoxy, correct.
Yes. 1-methoxy, 4-methyl benzene.
Yeah.
Toluene भी कह सकते हैं.
Yes. This is correct. 1 methoxy because the presence of ether. So 1 methoxy, 4-methyl benzene is the correct answers. Third.
Dibutyl ether.
That is for common name, madam. Directly we can say ether.
Butoxybutane.
Yeah.
Butoxybutane.
Fifth.
Cyclopentanone.
Cyclopentanone. Because this is from cyclic form, so ketone is present. So cyclopentanone is the correct answer. Sixth.
1, 2, 5, 6 tetrabromo octane.
3, 4,
Yeah. Seventh.
7 is
1, 2, 3, 4, 5, 6, 7, 8. Octa. 8 carbon, sir.
No, no, only you can see E3 is present. Don't count for carbon. When E3 is present, we can separate for 3 parts. When ether,
7, 7. Oh, count
wherever
number
it is
7.
present, no, don't consider for total number of carbon. When ether is present, we can cut for 3 parts. So E3 is 1 part and the remaining is another 1 part. Don't count for all carbon. When E3 is present, don't count for all carbons. So here E3 is present. So this 1 part cut, another 1 part cut. Here also E3 is present. So 1 part cut and here 1 part cut. So this is the ether, one of the ether. Here how many carbon is present? Only 1 carbon. Methyl is present. So this side how many carbon is present? So this side for 2 carbon is present. This side for 2 carbon is present.
dimethoxyethane.
1 and 2 carbon is present. So now consider this carbon. Cut 3 part. 1 part this, another 1 part. Here how many carbon is present? 1 carbon is present. So here 2 carbon is present. So 1,2 dimethoxyethane. That is the correct answer. 1,2 dimethoxyethane. So here you can see E3 is present. We can cut 3 parts. So oxygen, this side 1 part cut, this side 1 part cut. So what is here? Both sides same carbon. So same carbon is there. That's why butoxybutane. In case this side number of carbon is less, so that is combined with oxygen. So in case 2 carbon is present for this sides, 2 carbon is present for this side, that time what we can say, ethoxybutanes, ethoxy, less number of carbon combined with oxygen. So that's why ethoxyethane. Both carbon is same. So here also same for 3 parts. So what is this? 14. So 8. Sorry. So what is the name of 8?
Propine.
1 butane, sir. 1 butane.
Yeah, number of, so here you can see triple bond is cut here. So total number of carbon is 4 is present. So 1, 2, 3, 4. So 4 carbon is present. That is for 1 butanes. So ninth.
1,3 cycloheptadione.
Yeah. 1,3 cycloheptadione. Yeah, that is correct. 12th.
Three hydroxy, 2 in
Hept inode. Hept
3 hydroxy, 1 octane.
Hydroxy, madam. Here only one.
heptinode. 3 heptinode.
3 heptanol. 3 heptanol.
Octane.
No. Which one is
Octanol.
here, madam? Please consider.
Sorry, hydro.
Functional group is not end. Here functional group is present for middle positions. So now we can see that this is one of the end. This is one of the end. So this is one of the end. This is one of the end, because the functional group is present in middle positions. So that time we can any one side we can take for number. So this side carbon, first carbon, this is, or this is this end. Which end is carbon is first carbon?
Triple bonded.
Yeah. Here, because that time what I can say, the functional group is present for end. That's why here we can take for first carbon here. But this molecule, the functional group is middle positions. The functional group is present at middle position, not present at end. In case end is present, we can consider OH is the first carbon. But OH is present here, middle positions. So now we consider the triple bond is the first carbon. So this is the first carbon, and this is for the third carbon. 3. So what is the name?
3-hydroxy 1-octane.
Octanol.
No,
This is
octane.
octanol.
3-hydroxy 1-octane.
no hydroxy. This is alcohol. OL.
Yes, Professor.
Octanyl 3.
Yeah, 1-octane 3-ol.
1-octane 3-ol. Yes, Professor. 1-octane 3-ol.
1-octane 3-ol.
3-ol.
No need
Yes.
hydroxide. That is so only one functional group is present. So
Yes, Professor.
no need. That is. So 1-octane 3-ol.
1-octane 3-ol. Yes, Professor.
One faculty asking questions. No, the double one, triple one is. So now he clear.
तो दूसरे दे देंगे वो पढ़े.
Okay, now please explain 14, 15, and 16. Very fast. We can do for. We can explain another topics.
Undecayed.
So what is the? Yeah.
One
yes,
decade.
Yeah. And yeah, yes, correct. So next 15th. I don't know where is
1,
the
4 methyl.
1,2,
4
1,3, 1,3 dimethyl. 1,
Yes,
2, 3.
Not dimethyl. 1, 2,
Yes, yes.
3,
Yes,
4.
sir.
Oh, sorry, sir. Oh, yeah. Yes. No, sorry,
4
sir.
methyl
1,
hexane amine.
1, 2,
2 amine.
4, 5, 6. Exile, sir. Yes, sir. 1,
Hexane.
2, 3,
Madam? What is
4
the
methyl. 4
4
methyl.
methyl. Yes,
2
4
amino.
methyl.
4 amino. 4 methyl.
Yes,
2 amino.
hexane amine.
Yes, sir.
Hexane.
Yeah, first we can see for linear chain. First
Yes,
we
sir.
can check for linear chain.
Yes, sir.
Then you can check for functional groups.
Yes, sir.
So first the IUPAC name. First we can check for linear chain. How many carbon is present for linear chain? So how many carbon is present for linear chain?
6 carbon. 6
6
carbon.
carbon is present.
Yes, sir.
So that is next. Then for you end, which
Yes,
is one of the end, and another which is one of the end. So end is calculated.
Yes,
So
sir.
here this is one of the end, and
Yes,
this is one of the end. So the functional group is present at middle positions.
Yes, sir.
So very near distance, this carbon is present. So that's why this carbon is the first carbon. So this is first carbon. This is for second carbon, third carbon, fourth carbon, fifth carbon, and the sixth carbon. So the methyl group is present at the fourth carbon. So 2 amino 4 methyl hexane is the correct answer. 2 amino 4 methyl hexane is the correct answer.
Excuse me, sir.
Yes, madam.
In IUPAC nomenclature, amines these days
Ah.
we do not put amino group as a substituent, rather as methanamine. We replace E
Madam,
by
that is
amine.
for the common name, ma'am. I mean,
No, this is the IUPAC name, sir.
yeah, IUPAC we can call for amino,
Yes,
ma'am.
amine is the E. We replace E of the alkane by amine. The word amine. This is methanamine, ethanamine, propanamine, etc. This is the IUPAC nomenclature. In the old trend, we used to call it like
Oh,
amino
okay,
methane,
okay, madam.
amino ethane.
Okay, madam, we can check. No problem, madam. Thank you, madam. We can check. Okay, I will also check, madam. No problem. That is next 16th.
2-butyne.
16th.
2-butyne.
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 How many carbon is present, ma'am?
4 carbon.
Yeah. So for 2-butane is the correct. YNE, that is the correct answer. So next 18th.
3-phenyl propanol, ethanol.
What, ma'am?
2-phenyl ethanol.
No, alcohol is present. How you are saying?
Ethanol. Functional
No.
group is present on the side chain.
No, madam, alcohol is present.
Yes, so it is ethanol. 2 carbon atoms total. Chain with
Ethanol. That is
yes,
ethanol.
benzene group acts as a
Oil.
substituent. Phenyl.
Yeah.
This is
Phenyl, which carbon is only aliphatic, we can check for the
Yes,
linear
this is
chain, ma'am.
aliphatic.
Aromatic, we cannot check for linear chains. So
Yes.
aliphatic only we can check for linear chain. So that now you tell me. So how many carbon is present in aliphatic?
2 carbons, 2 carbon.
2 carbon. So phenyl, which carbon is connected? Phenyl groups.
Second carbon.
So yes, correct. So what is the answer?
2 phenyl
2
ethanol.
phenyl ethanol.
So 2 phenyl ethanol is the correct answer. 2 phenyl ethanol. Is the
Ethanol.
correct answer. Clear, madam? 2 phenyl ethanol is the correct answer. So now 19th.
This is hexene. One.
Madam, first you can check for linear chain.
Yes, sir.
Yes. 6
1,
carbon.
1,5 hexadiene, sir. 1,5
Yeah, that is okay. Another next you check.
Carbon.
substituents. Yes, sir.
Hexene
Second
diamine.
carbon, second
That is
carbon.
for
50.
branch chain. Yes.
Yes, sir. 2,5 dimethyl, 1,5 hexadiene.
Yeah, yes. Very good, sir. Correct.
Thank you, sir.
2,5 dimethyl hexa 1,5 diene also right.
Hexadiene.
1,5 hexadiene also correct. So okay. 20th.
20th.
Here also present for ether group. Already I told ether, whenever ether come, cut 3 part.
1 methoxypropane.
Madam, clear.
No,
First linear chain.
2.
Madam,
two,
first,
two.
yeah, correct.
2.
2.
Linear
Yes,
chain.
2.
First linear chain.
2 dimethoxypropane.
Yeah, correct, madam. Because linear chain, how many carbon is present? 3 carbon is
3
present.
carbon.
So 2,2 dimethoxypropane is the correct answer. 2,2 dimethoxypropane is the correct answer. 21.
2,6
2,6
dimethyl
dimethyl
contain
4
pentanol.
Madam, first you check linear chain.
7, 8,
heptanol.
7 carbon. Heptanol.
7 carbon is present. Okay, madam. Next, you can check for branched chain and the functional group.
6
Functional group is at 4th
Or not?
4th carbon.
2, 4 dimethyl.
2,6
2,
2,6 dimethyl
4
heptanol.
Yeah.
2,6
No. Please.
2,6 dimethyl.
Still mistake.
Yes, sir. 2,6 dimethyl heptan 4-on. Heptan
Yeah.
4-on.
Yeah, correct. 2,6 dimethyl heptane 4-on.
4
So 22.
This is 2, 4 dimethyl hep 4-in. Octene. It is octene.
2, 4 dimethyl.
2, 4 dimethyl hep 4-in.
4 octane.
Yes, sir.
Yeah. Yes, correct, madam. 23.
Not 23. 1, 2, 3, 4. 2, 6 dimethyl octane
2, 4
triene. Octane 2, 4
6
triene. Yes, 2, 4, 6 triene.
triene.
Octane triene.
Yeah. Octadiene, correct.
Octatriene.
2,6 dimethyl.
2, 4, 6.
4,6
Octatriene.
So next, here also ether also present 27. Already I told you whenever come ether, you cut 3 part.
This 1 methyl. This is ethoxy 1 methyl.
No, madam. You cut 3 part. Oxygen is there, na 3 part you cut. So oxygen is 1 part, and right side is 1 part, left side is 1 part. Total 3 part is present. Ether is 1 part, and the right side part is 1 part, and the left side part is another one part. Totally 3 parts there. Whenever ether come, the UPOC name, we can separate for 3 parts.
2-ethoxypentane.
2
No. 2-ethoxy.
Madam, what is the linear chain? How many carbon is present for linear chain?
2-ethoxy. This is 2-ethoxy pentane.
Yeah, linear chain 5 carbon is there.
5 carbon. 2-ethoxy pentane.
So this for right side less number of carbon. That's why oxygen combined with the less number of carbon. So ethyl plus oxy, ethoxy. That is for ethoxy. This is considered for this is considered for linear chains.
Pentane.
2-ethoxy pentane.
Yes.
Because single carbon single bond is present, that's why we can pentane. Okay, and okay, no problems. And 28
This is 2-methyl 2-mercaptane.
2-methyl-2-mercaptopropane.
Mercaptane.
yeah methyl propane 2-diol.
Yes.
So next 29 ma'am.
Ether.
So 29, this is okay.
2-propoxy. 2-propane.
Very careful. Little mistakes.
2-propoxy.
Propane.
2-methyl-ethoxy. 2-methyl-ethoxy.
Very okay. All are saying correct. Little mistake.
2-methyl-ethoxy. 2-methyl-ethoxy. And propane. 2-methyl-ethoxy. 2-methyl-ethoxy, 2-propane.
2
Methyl-ethoxy, 2.
Oh, sir,
Propane
how coming methyl ethoxy? That is not
This is 2
alkyl. Then you oxy.
2-propoxy 2-propane.
Epoxy.
2-propoxy 2-propane.
Yeah, little mistake. Correct, but a little bit miss. Little bit miss. So that is propoxy or isopropoxy.
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 Yes, ma'am. So iso is the very important. So 2-isopropoxy propane is the correct answer.
2-isopropoxy.
So next 30.
30.
So here, what type of functional group is present?
Ester, sir. Ester, professor.
Yeah, ester. When esteries will come, which part is very more number of carbon, that part we can connect with OA80. That is for ester, OA80 votes. So when number of which side is more number of carbon plus OA80, that is one part, and another one part is alkyl parts.
Propanoate, but it is 2-methyl propyl. It is 2-methyl propyl propanoate.
Yeah, yes, madam, correct. So this part, less number of carbon is present. So this part is present for propyl. Here also 2-methyl is present. So 2-methyl propyl propanoate is the correct answer.
Yes.
So linear chain is propane and one carbon is substituted, that is for the methyl. So this left side is propyl is present. So that is alkyl. So that is for 2-methyl propyl propanoate is the correct answer. 31.
This is 2-methyl.
2-methyl, 1-propanol.
Propanol.
2-methyl, 1-propanol.
You can check for linear chain.
Yes, sir. 1, 2, 3.
First-
Butanol. Butanol, sir.
Yeah,
2-methyl, 1-butanol.
2-methyl 1-butanol.
yeah, correct. And the final 32.
2-pentyne.
Yeah,
2-pentine.
So
Yes,
this is lost, then we can discuss our syllabus, no problem.
2-phenyl
Phenyl
ethanamine.
aminoethane. 2-phenyl aminoethane, sir.
Ethane,
Yes,
madam
ethanamine,
also they explained
ethanamine.
ethanamine also correct,
Yes,
or
sir.
aminoethane also correct. 2-phenyl. And
2-phenyl
34.
ethanamine.
34.
34 is ketone.
First, you can check what type of functional group is present. 34.
Aldehyde and
Aldehyde. Aldehyde.
aldehyde and alkene, sir. Aldehyde and alkene.
Aldehyde.
Yeah, aldehyde is.
3-phenyl propanol. 2-propanol.
Yeah, correct, madam. 3-phenyl, 2-propanol.
2-propanol.
Yes. Next, 35. Already we
Already
explained.
discussed.
35.
Already we have discussed.
36.
36. 1, 2, 3, 4.
3,
3
dimethyl,
dimethyl,
1 butane.
Butane. Yes.
1
Yeah,
butane.
yeah. Yes, correct. And 38.
38 is ketone. 1, 2, 3, 4. 3, 4 dimethyl.
3, 4 dimethyl, 2, 5 hexane dione.
Yes, 2, 5 hexane dione.
Dione.
Yeah,
2,
yeah.
5
Yes,
hexane.
yes. 3, 4 dimethyl.
Methyl
Hexane 2,
dione.
5 dione. 2,
Yes.
5
5
dione.
dione.
Is the correct answers. So now we can explain for UV spectrophotometry. So this is also very important in our topics for analytical. Maybe now all are refers. Okay.
Yes, Professor. Thank you, Professor, for the IUPSC. Thank
Okay.
you.
So now UV visible spectroscopy. So that is very important. So here electromagnetic radiations and the wavelength. So here this is for the different type of electromagnetic radiations present here. So for here for gamma rays. So this is for gamma rays is for less energy. Gamma rays is what is the wavelength is 0.001 m because highest energy. So here for highest energy. Then for X-rays, so what is the wavelength? 0.01 to 10 nanometers. And UV visible, that UV visible radiation is UV and visible. So what is the UV range? 200 to 400 nanometers. And the visible range is 400 to 800 nanometers. And IR radiations, near IR and middle IR and far IR. So near IR is 0.8 to 2.5 micro, and middle IR 2.5 to 1.5, and far IR is 15 to 200 micrometers. So and microwaves. So microwaves is 0.01 to 1 meters, and the radio wave is 1 to 10 to the power of 7 meters. So this is for the wavelength matches. So when wavelength is higher, the energy is very less. So energy is inversely proportional to wavelength. So that point is very, very important. The energy is inversely proportional to wavelength. The energy is inversely proportional to wavelength. So what is the wavelength? So what is the wavelength?
Distance between the two crests.
So wavelength, the difference between two
The
crests,
or troughs of it.
two trough. So two crests, this is for CC. See, that is for two crests. The difference between the two crests, that is for the wavelength, or two troughs, that is for the two troughs, that is called for the wavelength. It is denoted by lambda. This denoted by lambda and Armstrong and micro and nanometers, and so this is etc. So many units there for wavelength. And what is the wave number? Any idea?
Inverse of lambda. Inverse of lambda.
Yeah, inverse of lambda. But what is the meaning of wavelength?
It is equivalent to frequency.
Number of waves passed
in a particular
space of 1 centimeter. So number of waves passed through a space of 1 centimeter. So that is called for the wave number. So reciprocal of wavelength. This is for the reciprocal of the wavelength. It is denoted by mu bar. So the mu bar is here mu bar is 1 by lambda, and then how this can, okay, so this is the, what is the unit is centimeter inverse. The wave number, what is the unit is centimeter inverse. So this is for the wave number. So now you can clear what is the wavelength and what is the wave number. So next slides we can explain here what is the frequency. So this is also very important. Madam, what is the frequency?
Number of waves passing through a particular point in 1 second.
Yes, correct. The number of waves which can pass through a point in a during of 1 second, in duration of 1 second. So that is called for the frequency. The number of waves which can pass through a point in a duration of the 1 second. So that is called for the frequency. It is generated by mu and inversely proportional to the wavelength, and inversely proportional to the wavelength. So mu proportional to inversely proportional to wavelength. So already we know mu equal to c by lambda. What is the c? The velocity of electromagnetic radiations. Here c is velocity of electromagnetic radiations. So already we know what is the c value, nearly for 3 into 10 to the power of 10 centimeter per second. So that is for the velocity of the electromagnetic radiations. So next, for what is the unit cycles per seconds. Here second or hertz we are using for the frequency units. And the next, energy. What is the, so energy represented already we know it is capital E. It is denoted by capital E. E equal to h nu. Already we know what is the h, that is for the Planck constants, and mu already we know the formula. So c by lambda. So h equal to 6 by 6.6226 into 10 to the power of minus 27 Earth and second. So this is for the energy. So now please calculate. Please take paper and pen.
1 by
Calculate the wave number for 2.5 micron wavelength, micro wavelength. Calculate the wave number.
0.4.
4 into 10.
Calculate the wave number for 2.5 micro wavelength. So what is the
0.4.
answer?
4 into 10 raised to the power 3.
4 into 10 to the power minus 1 or 4.4.
Yeah, we will check, ma'am. No problem.
No,
Another
it is
faculty
four.
members.
Okay.
Please
It is
try.
4 into 10 raised to the power 3.
Okay, we can check, ma'am, whether correct or wrong. We can check the next slides. But other faculty members, you can also try. Calculate the wave number for 2.5 micro wavelength.
4 into 10 to the power minus 3 centimeter inverse.
So we can move for
4
next.
4 into 10 to the power minus 3. 4 into 10 to the power 3.
3, yes.
3
Yes.
centimeter inverse.
4 into 10 raised to the power 3.
Okay, ma'am. We
Centimeter
can
inverse.
move for next slides. And what is the answer? Exact answers we can see. So what is the answers? Yeah, this is the correct answer, madam. 4,000 centimeter inverse. That is the correct answers. So calculate the wave number for 2.5 micro wavelength. So this is for the correct answers. Any doubt, ma'am?
Yes.
Yeah.
Correct answer.
Any others? Any doubts? How
No doubt.
we can calculate when we are given for wavelength? How we can calculate for wave numbers? So this is the formula. Any doubts?
No doubts.
Yes, ma'am. Okay. Next, calculate the frequency for 3800 Armstrong wavelength. Calculate the frequency for 3800 Armstrong wavelength.
G into 10 to the power 10 divided by this component 10 to the power minus 9. Sir,
1 into 10 raised to the power minus 3. Approximately 1 into 10 raised to the power.
Approximately.
Yes.
Because C is 3 into 10 to the power 10 and 3.8 into 10 to the power minus 9.
Yeah, we can check, ma'am, whether correct or wrong. Try to another faculty, total 60, nearly 60 faculties here. But nearly among 10 or nearly 10 faculty members only they are telling that telling the answers. They are given the answers, but others, I don't know what doing for others. Okay, now we can check for what answers. What is the correct answers? So this is for the correct answers. 7.8 into 10 to the power of 14 per second. That is the correct answers. Any doubt, ma'am?
Minus 8 and plus 8. Yes. Yes, sir. No doubt.
So please check
No
the
doubt.
answer.
No
Yeah.
doubt.
Okay.
So now we cannot use this calculator.
So now calculate the energy for 3800 Armstrong wavelength. Calculate the energy for 3800 Armstrong wavelength.
Sir, 5.23.
Yeah, we can check, ma'am.
5.23 into 10 to the power 36.
20. 0.5 into 10 raised to the power 25.
0.5 or 5.2,
Yes.
whatever.
Yes.
So yes, 5.23. What is the answer, madam?
5.23 10 to the power.
Yeah. Yes. The correct answer, ma'am. So your answer is the correct answers. So any doubts? This is the correct answer, ma'am. This is the correct answers. Any doubts?
No, sir. No, sir.
Oh, sir.
So next, in UV spectroscopy, the absorption law is very important. What is the absorption law? So I0, I0, what is the I0 or I0? The I0 is for the instant radiations, and I is the transmitted radiations. I0 is the instant, I0 is the instant radiation, and I is the transmitted radiations. So this is for the cuvette. The sample is present here. For example, incident radiation is here 100%. So what is the transmittance appear 95%. So how many percentage is absorption? Incident radiation is 100% is present, and the transmittance appear for 95%. What is the transmittance radiation is 95%. So how much absorption is present? How much percentage the absorption is present?
Log
Sam,
of I naught upon.
dear faculty members.
This is log of I naught upon I.
Oh, no, simply I am asking. The incident radiation is 100%, and the transmitted radiation is 95%. So remaining how many percent is present?
4%, 5%.
5%. So that is for absorptions. So that is for the absorptions. So transmitted we know for 95%. So the remaining part that is for the absorptions. So only for the 5% is for the absorptions. Case 1 and case 2, if sample solution is transparent, if sample solution is transparent means 100% transparency. So what is the absorptions?
0.
0. Yeah. So the percentage absorption is 0%. And what is the transmittance? That is for the 100%.
100%.
So here I0 equal to I. So here I0 equal to I. That is the correct answer. In case 2, if sample solution is not transparent, the absorption percentage more than 0. The absorption percentage more than 0, and the percentage of transmittance less than 100%. So here I not greater than for I. Here I not greater than for I. So this is for the absorption law. So on UV spectroscopy, this is the absorption formula I naught by I, and the transmittance I by I naught. And what is the absorption formula? Equal to log 10. So this is 1 by T. So A equal to absorption, T equal to transmittance. So T equal to I by I naught. So that is for 1 by T equal to I naught by I. So this is for equation 1. And we can check, we can replace the A equal to log 10, I naught by I equal. This is equation 2. So what is the absorption law? What is the Lambert's law?
Lambert's law.
What is the Lambert's law?
Amount of radiation monochromatic radiation passing through a solution is directly proportional to the concentration of the solution or path length.
Yes, correct. When a beam of the monochromatic radiation is passed through the absorbing mediums, that is for the solution part. When a beam of monochromatic radiation is passed through the absorbing medium, then the decrease in the intensity of radiation, will be directly proportional to thickness of the solutions or path length. Thickness means path length. Directly proportional to thickness, that is for the path length of the solutions. So this is for the Lambert's law. So that is for A equal to log 10 I naught by I proportional to L. So L means path length, and the epsilon. So A directly proportional to L, and A equal to epsilon L equal to path length, and epsilon is molar extinction coefficient or molar absorptivity. That is for the epsilon. And the Beer's law. What is the Beer's law, ma'am?
It will depend on the concentration.
Yes.
Path length and the depend on the concentration.
Yes, madam, correct. When beam of monochromatic radiation is passed through the absorption medium, then decrease the intensity of the radiation will be directly proportional to the solution of the concentration of the solutions. So A equal to log 10 I naught by I proportional to C. So A directly proportional to concentrations. So A equal to epsilon with the concentration. So this is the concentration of the solutions. So what is the Lambert-Beer's law or Beer's-Lambert's law? Lambert-Beer's law.
That is, the absorption is dependent upon the path length as well as the concentration of the solution.
Yes, madam. Yes, correct. So length into concentrations. So this is for the formula of Beer-Lambert's law. So now we can calculate. Madam, please note 249. A 249 nanometer of if 249 nanometer of paracetamol, paracetamol 0.330 absorbance. A 249 nanometer of nanometer paracetamol 0.330 absorbance when using 0.5 centimeter thick cuvettes, when 0.5 centimeter thick cuvettes, and the epsilon equal to, what is the epsilon value? 0.165 into 10 to the power of 3 liter per mole centimeters. So now what is the concentrations? Please see the slides. Clear answer is there. If any you have doubts, please ask me. I will explain to you. So we can move for next slides. So here UV visible spectroscopy is there. So this is for the UV visible spectroscopy. Madam, so this is for absorbance for y-axis and axis is for wavelength. So the how the peak appear, left to right or right to left? This rectangular peak, how appear? Moving
Left to
this
right.
side for left to right or
Left to right.
right to left?
Left to right. Now, this is right to left.
Left to right or right to left? The peak appear.
Right to left.
The absorbance peak appear when where start from left to right or right to left?
Sir, right to left.
Left, right. Absorption increases with the increases of the wavelength. And that particular wavelength maximum
No,
lambda
that is
maximum
okay. Where start the initial
Left to
point?
Right to left.
Yeah, correct, ma'am. Your answer is correct. Right to left.
Yes,
Why, ma'am? Right to left.
right to.
The scanning right to left is the correct answer. Why, ma'am? Right to left. The peak is appears.
Because we measure it in frequency wave number units. What's of
Oh, very important point is there. Please think. Take for a few minutes. What is the important point? Why right to left? Sorry, why left to right? Sorry, right to left.
right to
Why
left.
we can take for right to left?
Visible to UV, sir. Visible to UV range.
Yeah, that is okay, sir. But one of the point is very important point is there. So wavelength is high, then energy is
Low.
low. Yeah. So when here start, energy is very high. So that molecule exited very fast for exited states. Move for very fast exited states. So here energy is very less. That's why, because energy is inversely proportional to wavelength. That's why we can scan from this side 800 to 200.
Yes,
So that is the
6,000,
correct answer.
4,000.
Any idea? So the in UV visibles, 4 type of transition is possible. Sigma to sigma transitions, and N to sigma star transition is possible, and pi to pi star transition, and N to pi star transition is possible. So already you know sigma to sigma star. Slide is visible.
No,
Yes, sir.
Professor. Yes, Professor. Visible.
Yes, sir.
So say sigma to sigma star. Here energy of 150 nanometers. The energy of the wavelength is 150 nanometers. So this is called for vacuum UV regions or below 200 nanometers. So this is for the below 200 nanometers. And what type of sample appears for below 200 nanometers? That is for hydrocarbons, for example, methane, propane. So this is possible only for saturated compounds. The saturated compound only possible for sigma to sigma star transitions. And the next, N to sigma star transitions. So what is the N? What is the meaning of N?
Don't ethyl chloride, alcohols, and
Here, what is the meaning of N?
Non-bonding electrons, sir. Lone
Yes.
pair electrons.
Yeah, non-bonding electrons. So,
non.
so that's why we can call for N sigma stars. So where is the N sigma star is presence? So where is the non-bonding, the lone pair of electron is presence?
Heteroelement.
Which common? Heteroatoms. Yeah, it's correct. So the approximately for this range 175 nanometers. So approximately in this range for 175 nanometers, when any heteroatom is present in the saturated compounds, that is very important, because N to pi star, that is what happening, N to sigma star. So heteroatom presence of saturated compounds. N to pi star.
Carbonyl compounds,
Yeah.
heteroatom as well as
Yes.
pi bond.
With unsaturated, N to pi stars, unsaturated. That is right. So here, when any heteroatom is present in the saturated compounds, alcohols, aldehyde, ketones. So this is also presence. And water. So water, what is the wavelength? 167 nanometer. And methyl chlorides and the methanol. So this is for the N sigma star examples. And the pi to pi star transitions occurs. So this is for more than 200 nanometers. More than 200 nanometers. Any double or triple bonded hydrocarbons and aromatic compounds. It will happen for pi to pi star transitions. And the N to pi star transitions occurs more than 200 nanometers. For example of carbonyl compounds, the heteroatom with the unsaturated. So what is this 350? So what is this we call for 350?
Wavelength of maximum absorption.
Yeah, wavelength of so that is correct. What happening here? 350 nanometers.
Maximum absorbance.
Maximum number
Excitation.
of molecules are absorbing at this level.
Excitation of electron at this.
Yeah,
particular-
yes, sir, correct. Here, excitation of the electrons, HOMO to LUMO. So that is the maximum absorbance. That is for 350 nanometers. That is we called for lambda max. So this the 350 is the transition is occurs HOMO to
LUM.
Sir, unmute your mic.
Madam, audible?
Yes, sir.
So what is the chromophore? The chromophore, already we know about what is the chromophore. Chromophores are covalently bonded with any compound and responsible for absorption of the UV visible radiations. For example, aldehydes and ethylene and carbonyl compounds. This is example of the chromophores. Here, what transition is occurs in chromophore? Pi to pi star transition and N to pi star transitions. So this type of transition occurs only for chromophores. So C double bond C here, what transition occurs? Pi to pi star transitions, and here heteroatom is present. So N to pi star transitions occurs. So this is for the chromophores. And what is the axochrome? Madam, what is the axochrome?
The oxochrome is a structure feature or the functional group which itself doesn't absorb in the UV radiation. But once
Yes.
it is attached to the chromophore, it increases the value of lambda maximum.
Yes, madam, correct. So this is the example. The axochrome is defined as any moiety which does not shows any specific color or absorption when separated. But when compound with the when combined with any chromophores, it increases the absorption wavelength. Then combined with any chromophores, it increase the absorption of the wavelength. So that's for longer wavelength. So by the formation of the new chromophores, for example, OH, NH2, and NHR, and the diol combo, etc. This is for the axochromes. So for example, so this is for the chromophores axochrome. For example, when benzene is there, what is the benzene? 255 nanometers. When added to amine groups, so what is the form of aniline? That time, what is the range of the lambda max value? So nearly for the lambda max value, so nearly for 280 nanometers. So when the addition of this is present, only benzene is present. When addition of amine compound, that is for the axochrome. When addition of axochrome, that time the lambda max values increases. So so this is for the for examples. And what factors affecting for absorption in UV visible spectroscopy? Madam, what kind of factors affecting the absorption of UV visible spectroscopy?
Please repeat the question.
May somebody disturbance any? I don't know. Slide is visible.
Yes, sir.
Yes. Madam, what factors affecting for absorption in UV visible spectroscopy?
Sir, which are affected the... Okay, continue, ma'am. Continue, madam.
It is the solvent.
So absorption compound, that is for chromophore, the axochrome, and the solvent effect. The benzene nearly for 255 nanometers for benzene, and the carbon tetrachlorides nearly for 265 nanometers. So and the chloroform nearly for 240 nanometers. So avoid these solvents because this is the affecting for the absorptions. And the temperatures, low temperature is suitable for the UV visible spectroscopy. So this is very important, and higher it gives for higher absorptions. And next for inorganic materials. Inorganic materials are also affecting the absorptions because increase the absorptions for complex inorganic moieties or single inorganic moieties. So what is the complex inorganic moieties? That is CrO4 minus and MnO4 minus, that is for complex inorganic moieties, and the single inorganic moieties, silver, gold, etc. So this is also affecting for absorptions, UV visible absorptions. So next, So already you know about for what is pathochromic shift and hypsochromic shift and hyperchromic shift and hypochromic shifts. So what is the pathochromic shift? That is called for red shift.
Red shift. Increase in the
So how
value.
do the wavelength increase? What is the reason? Why? What is the reasons wavelength is increases?
Conjugation increases due to conjugation. A lone pair of
Yeah. One of the point is conjugation
HOMO, LUMO difference decreases.
and chromophore, axochrome, and the
Yes.
solvent effects
Yes,
and
solvent.
increase. So this is the reason for increase the wavelength. So that is called for the red shift. So this is for pathochromic shift and the hypsochromic shift. What is the
Reverse.
hypsochromic shift?
When we remove
is
the
for-
conjugation.
That is called for blue shift. That is called for the blue shift. Same, the reverse. removal of chromophores and the removal of oxochromes and solvent effect also is involved in this blue shift and the removal of the conjugations. That time we can remove of conjugation. Definitely the wavelength decreases. So the wavelength decreases. The red shift move to blue shift. So that is for the okay. This is called for the hypsochromic shift. And what is the hyperchromic shift?
Increase in the value of molar extinction coefficient, absorptivity.
Yeah. Increase the yes, madam. Increase the for molar absorptivity. Increase the molar absorptivity. What is the reason why the absorptivity suddenly how increases?
Heterochromic shift is accompanied by this shift because the number
Yeah.
of molecules absorbing
Pyridine presence.
wavelength
Madam, I will explain. Pyridine presence. So what is the wavelength? 257 nanometer. So what is the maximum epsilon? 2750 is the presence. So that epsilon. When methyl is substitute, so when methyl is substitute, that time, so that time for 262 nanometers and the lambda max equal to 3660. So this type the molar absorptivity is when substitute for methyl groups, that time the molar absorptivity increases. So this is for the example of increases the molar absorptivity, that is for hyperchromic shift. So what is the hypochromic shift? What is the hypochromic shift?
decrease in the value of molar absorption.
So this is the biphenyl is present. So diphenyl is present here. Biphenyl. So this is the biphenyl. So 250 nanometers. And what is the molar absorptivity? Is 19,080. And when substitute for methyl group, that time the lambda max value also decreases 237 nanometers. And the molar absorptivity also decreases 10,250 is there. So here, so this is the reason for the this is called for the hypochromic shift. Hypochromic shift.
Why the value decreases?
Yeah, I will explain, madam. Because electron withdrawing group is present, or electron withdrawing or electron donating group is. I will explain. The slide is there. So when the electron withdrawing group is present, the time that the wavelength is decreases. I will explain. The next slide is come. So this here with GR, VI, B, GYOR red, and this is for the violet color is there. And this is for the principle of the UV visible spectroscopy. So how working for UV visible spectroscopy. So this is for radiation source. This is for the radiation source. And this part, the red color part, this total part is called for monochromator. So this is for the monochromators. The monochromatic, two monochromatic is present. One present for the entrance slides, the another one present for exit slide. This entrance slide monochromator what is the role? When the polychromatic wavelength the polychromatic convert to monochromatics. So when the radiation source enter the monochromatous, that time the polychromator is convert to monochromatous. That's why we are using for entrance light monochromatics. So this is for the collimator lens. So this lens, why we are using the direction little change. The collimator, what is the role? Little the direction is little change. Direction is little change. So when this is for reflecting lens, gratings. Sorry, this is for gratings. So the gratings, the 1 mm gratings, nearly for 1200 to 1400 grooves is present. So 1 mm gratings, how many present grooves? Nearly for 1200 to 1400 grooves is present. We are using for gratings or prisms also using. Why the grating or prisms are we are using? Because that is separate for 7 parts. Already I told Vibs here. So the separating for 7 parts. They are giving for 7 parts. That's why we are using for gratings or prisms. Then this is for this lens is reflecting. We are here using for lens. This lens reflecting and enter to the monochromatic exit slits. So what is the role of exit slits? The unwanted wavelength removes. Only fixed wavelength, what wavelength we need, that only the monochromator allowed to chopper. So this is for chopper. So what is the chopper role? This chopper role equal parts to separates. So what is the role of chopper? Equal parts to separate for reference sample and reference and sample parts. Reference part and sample parts. So here move for half part moving, one part moving here, another one part for moving for sample sites. So one part moving for reference side and another part half part moving for the sample parts. So here that is the role of the choppers. So reference, this is the double beam UV visible spectroscopy. Double beam UV visible spectroscopy. Then enter the detectors. So then enter for the UV visible, the radiation enter for detectors. So the detector convert signal. The signal we can record at the amplifiers. And the sample part also moving to detectors, and the detector and the radiation convert to signal. The signal is recorded. The signal is signal is recorded in amplifiers. So here we can see mono instrument in 2 type of instruments is possible. Single beam and double beam is the possible. So here using for single beam reference cuvette one there, here sample cuvette. So that is for the double beam, and the single beam also we can use. And what is the radiation source? Here 2 lamp we can use. What is the radiation source? 2 lamp. Hydrogen deuterium lamp we can use. So and then tungsten lamp also we can use. So hydrogen, why we are using for 2 lamp? Because of the hydrogen deuterium lamp, the range of 200 to 375 nanometers. Then the intensity decreases. So then that's why we can use for another 1 lamp for tungsten filament. We can use the tungsten filament lamp range 375 to 800 nanometers. So, but tungsten lamp filament is very long nanometers. But in UV visible range 375 to 800 nanometers. And then monochromators. So what is the monochromator part is present for entrance lights and the collimator lens, gratings and reflecting lens and the exit lens. This part is called for the monochromators. And detectors. So detector we can use for 3 type of detector. Porto multiplier tubes, that is called for PMT, and the Porto diode array detectors, that is for PDA. Porto diode array, that is PDA, and the charged coupled detectors. So 3 type of detector is possible in UV. And the cuvettes used for quartz, that is for UV visible. Glass glass only for visible only visible only possible. So we can use for quartz cuvettes. Then for what is the Porto multiplier tubes? So when the photon, the radiation, enter the cathode, this is the cathode pots. So this is for the cathode pots. When the photon enter the cathode pots, that time the cathode is received the electrons. When this is for diodes. So what is the meaning for diode? The multiplication of electrons. That is called for the, that is the function of diode. Diode different, diode is different. So diode, what is the meaning of diode? That is for the multiplication of the electrons. So here one electron is there. Then going for this diode, the electron is multiplications. Then coming for this diodes. So then coming for this diode, the electron is increases. Then final going to for the anode pots. So this pot, one pot connected for cathode pots, the another one pot is connected for anode pot. These two pots connected to amplifier. So how many electron is produced? That type of the signal is appear. Then we can observe. The signal is in recorded to amplifiers. So next, what is the Porto diode array? Porto diode arrays, diode or diode is for the electric signal, the electric signal from radiations. So this is for the diode is we can use, that is for the use. And what is the range for this? So this is for 200 to 300, 200 to 800 nanometers, and used for HPLC. And CCD, this is silicon surface are used for catch the photons. This is charge coupled diodes. Silicon surface used to catch the photons. The silicon surface are used to catch the photons from the UV ray, from the radiations. So the radiation converted to signals. So this is the principle of the UV. So next, so this is for the simple. So this is for single beam detectors. There is first solvent, blank solution. We can the cuvettes we can put for solvent. Then for then take for solvent cuvettes. Then we put for the sample pots. So we can analyze the same UV visible spectroscopy. This is for single beam UV visible spectroscopy. So already I explained. So acid to aldehydes. So this is for the acid to aldehyde is there. So how many type of transition occurs? Dear faculty members, this compound, how many transition occurs possible for acid to aldehydes?
N pi star, pi star,
Pi to pi star transition.
sigma pi star. N pi star most
N to
prominent,
pi
sir.
star
Pi star most prominent. N pi star and pi star.
Okay, next sigma to sigma star is not possible.
Yes, sir. Sigma to
Yes,
sigma
sir.
star also. Sigma pi star
Yeah.
also possible. Sigma star also
is
possible.
possible.
Yes, yes, very good, sir. So this is total possible. This is possible, but a total possible. This is the possible. Sigma to sigma stars, and pi to pi star is possible, and n to pi star is possible, and n to sigma stars. So total 4 transition is possible. Sigma
Really?
to sigma star, and pi to pi star, and n to pi star, and n to sigma star is the possible. So now we explain the cyclohexane. What transition is occurs? Cyclohexane.
Sigma
Sigma
star.
to sigma star.
Propane,
Sigma to sigma
Sigma
star.
to sigma star.
ethene,
Pi to pi star.
1,3 butadiene,
Yes, sir.
Pi
Pi
to
to pi
pi
star.
star.
Sigma
And
star.
sigma to sigma star.
Benzene pi
Benzene.
to pi star. Sigma star.
Okay.
This
Here,
also, sir. Pi to pi star.
And sigma to
Yes.
sigma star.
Sigma star. Yes, sir.
so cyclohexane, sigma to sigma star transition is possible. So here pi to pi star transition is possible. So here for, so this is okay. And here what type of transition is possible?
N sigma star, sir. N sigma star.
Ethanol,
And
Yeah,
N sigma star.
sigma star. Yes, sigma to sigma star.
N to sigma
yeah.
star.
Sigma
So
star.
here
N
sigma star transition is possible. So this is for less than 200 nanometers. So ethanol and ethanamine and ether can be used as a solvents. So less than 200 nanometers, that's why we can use for solvent. So next, this type, what transition is possible?
N
Pi to
pi
pi
star,
star.
sir. N pi star, pi star.
Pi to pi star transition.
So N2 pi star transition is possible. N2 pi star transition is possible. Pi 2 pi star transition is not possible. N2 pi star transition is possible.
Sir, what is the reason behind it? In this
What ma'am?
aldehyde pi to pi star transition is not possible. But
No,
why?
aldehyde only C double bond O is presence. C double bond O, not C double, not carbon carbon single bond is presence. C double bond O, madam, that is for only for N non-bonding transition occurs,
Okay.
not pi transition.
Thank you, sir.
Both types of transitions are possible.
Yeah, yes. Both transition is possible. Correct, ma'am. So energy order. So this order is low and so less than 2 nanometer. That is for high energy. So this is for the low energy. So so ethanol. So ethanol 2 type of transition is possible. Sigma to sigma star and N to sigma star transition is possible. So what is the absorb? Less than 200 nanometers because of sigma to sigma star and N to sigma star is possible. That's why less than 200. Acetaldehydes. So acetaldehyde 2 possible, ma'am. Sorry, madam. 2 is possible.
Yeah,
Pi
yeah,
2 pi
that's
star
why
is
I
possible.
asked it.
Yeah. Pi 2 pi star and N2 pi star is possible. Acetaldehydes. So UV visible spectroscopy less than 200 and 200 to 400 near UV and 400 to 800, that is for the visible parts. So this is for the chromophores and the exochromes. So it is very useful for identification of the functional groups and identify presence of unsaturated and the conjugation. And the conjugated decrease energy and conjugated, the conjugation decreases energy and increase the wavelength. The decrease decrease the energy, increase the wavelength. So okay, that is the okay. So now you can see this is for the homo and lumo parts. So gap is decreased. Homo and lumo, the gap is decreased. So high energy is occupied. The gap is homo lumo gap is decreased. The high energy is occupied. When homo lumo the gap is increased, that time low energies that is for low energy. So high energy occupied. The gap is decreased. High energy is occupied. The gap is increased. Low energies. Low energy. So this is for the pathochromic shift. So already I told what is the so why it is called for red shift, because of R is here higher wavelength. So that is called for the pathochromic shift, red shift and high lambda. So this is hypsochromic shift. So no need to so this is okay. So this is no need to explain. Yes, ma'am. Now, what is the lambda max value? So, what is the lambda max value? This is also very important for lambda max value. What is the very important for 1,3 butadienes? That is the main important for organic molecules for UV visible spectroscopy. 1,3 butadienes. In case the presence of 1,3 butadiene, the definitely the wavelength is absorbance. The absorbance of wavelength is possible. So there are there are many types of present. Acyclic butadienes. So acyclic butadiene. This is called for acyclic butadienes because this is not for cyclic form. Slide is visible, ma'am.
Yes, sir.
So this is for
Yes, the slide is
acyclic form.
visible.
So this is for acyclic form. So this is for the acyclic form, and this is also for acyclic form. So what is the range? 270 nanometers. So acyclic conjugated ion is present 270 nanometers. So this is keep in your mind, keep in our minds. The acyclic butadiene is present. What is the basic value? 270 nanometers. So this is one type of acyclic butadienes. So another second type, homonuclear conjugated ions. Homonuclear conjugated ions. What is the homonuclear conjugated ions? So you can see two ring is possible. This ring is A, here B is possible. So where is present for 1,3 butadiene? The 1,3 butadiene present one ring or two ring? Madam,
Two ring. Two rings.
One ring.
second compound.
One ring.
One ring.
One ring.
The second compound 1,3 butadiene is possible. Only one ring or two ring is present for one ring or two ring?
Two rings. Exocyclic double bond with respect to other ring.
No, madam, only present 1,3 butadiene present only for A ring.
Homoannular, one ring.
So only present A ring, only present for
One
butadiene.
ring. Homoannular.
So this type of dienes called for homoannular conjugated dienes.
Yes,
Homoannular conjugated dienes. So what is the basic value? 253 nanometers. So what is the basic value for acyclic butadiene is present? Basic value 270 nanometers. And the homonuclear conjugated diene is present. So what is the value? 253 nanometers. So next, madam, please see the third. The double the butadiene is present both A or B ring or
Both.
only one is present.
Both the rings.
So both are possibles. 1,3 butadienes. So this type of conjugated diene is heteroannular conjugated dienes. So this type of diene is called for heteroannular conjugated dienes. So what is the basic value? 250 nanometers. 250 nanometers. So acyclic butadiene, that is for 270 nanometer, and the homoannular conjugated diene, that is for 253 nanometers, and the heteroannular conjugated dienes, that is for 250 nanometers. So extra double bond, in case double bond is present for extending conjugations, the double bond is present for extending conjugation. What is the basic value? 30 nanometers. In case one more double bond is present, that value we can calculate, we can give the value for 30, one double bonds. In case two double bond is present, so 2 into 30, 60 nanometers. We can calculate for, so one double bond more than 1,3 butadiene, that is for the basic. Then more than one double bond is present, we can calculate for 30 nanometers. One double bond is present, 30 nanometers. In case more than one double bond is present, 2 into 30, that is for 60. So basic value into what is the double bond is presence. And this is for alkyl substituted. So this part, this methyl group is for the alkyl substitute or ring residue. We are called for alkyl substitutes. So this is for butadienes. So butadiene and remaining part we can cut. That part called for residue or substitutes. So what is the value? 5 nanometers. We can focus only for 1,3 butadienes. 1,3 butadiene only focus. Then remaining part we can cut. So that is the linear chain part. Remaining part we can substitute that part, or a ring residue we can call for, that is for substitute or ring residue. Cut that part. How many part is cut? In case 4 part is cut, that is for 4 into 5 nanometers. Each residue is 5 nanometers. In case 4 residue is present or 4 methyl substitute is present, 4 into 5, that is for the 5 nanometers. So here we can see what is the exocyclic double bonds. So this value also we can consider. What is the value? 5 nanometers. So exocyclic double bond is present in this organic compound. What is the value for 5 nanometers? 5 nanometers. So what is the exocyclic? This is the ring. The ring outer side, 6 carbon is present. Any corner double bond is present. The 6 carbon is present. The ring outside, any double bond is present. That is for the exocyclic double bonds. That is called for exocyclic double bonds. So now you see the ring A. Ring A, exocyclic double bond is present or not? 6. Slide is visible. 6.
Yes, sir. In both the rings, for both the rings, there is an exocyclic double bond.
Yes, ring A. First you focus for ring A.
There is an exocyclic double bond.
Is present. Any outer side double bond is present. First to focus
Yes.
for ring A.
Again,
So
there is
exocyclic
one-
is present or not?
Yes.
Yes, presence. And focus for B, the ring B. Only focus for ring B. Any outer layer double bond is present or not?
Yes.
The ring outer side is. So
Yes,
total
okay.
exocyclic is present. Total 2 exocyclic is present in these compounds. Any doubts for others, faculty members? Any doubts?
No, sir.
Okay. So this is for example. So this is for hetero or homo, madam.
Homo.
This is heteroannular or homoannular?
Homoannular.
Yes, homoannular. So what is the basic value? 253 nanometers, and more than one double bond is present. So that is
Extended
for
to
30 nanometers, 30 nanometer. And how many ring residue? So the here this is one of the end. This is another one of the end. The conjugation start from here to here. Conjugation start. So where is the conjugation starting point and ending points? So starting point cut and the ending point cut, and that middle substitute part also cut. So how many parties will cut? So nearly for 3 parts. This is starting point. So here one cut, and this is substitute point. Here also one cut. This is the end point. So this is also one cut. So 3 ring residue is present. So 3 into 5, 15 nanometers. And the next for exocyclic double bond is present or not. So
Yes.
ring A, exocyclic present or not? Ring A.
No.
So ring B.
Yes.
So what is the value? 303 nanometers. So this compound, the wavelength, the lambda max wavelength, what is the wavelength? 303 nanometers. So this is for 3 nanometers. So this now you can see this example. How many? This is for homoannular or heteroannular?
Heteroannular.
Heteroannular, because of A and both are involving the 1,3 butadiene, ring A and ring B presents. So that's why this is called for heteroannular conjugated dienes. So already I told what is the basic value, 250 nanometers. Okay, 250 nanometers, and how many ring residue? So this is starting point, this is the end point. So how many ring residue there? 4 is there. So 4 into 5, 20 nanometers. And how many exocyclic double bond is present?
2
Exocyclic double bond is present. So total for 245 nanometers. So this is for 245 nanometers. And so okay. So this is for so okay, no problems. So this is for example of. So this is an example of this is example of the hetero. So Woodward-Fisher rules, conjugated dienes, that is for chromophore, substitutes, that is for the axochromes. So this is for base value. This is the increment. The substitutes, that is for increments. The chromophore, that is called for the base value. So the Woodward-Fisher rules, the heteroannular diene is present, that is basic value 240 nanometers, and the homoannular diene is present, that is for 253 nanometers. So exocyclic double bond or ring residue is present. What is the increment value? 5, and the extended conjugation is present, that is for the 30. So now now madam explain what is the lambda max value this compound.
This is 2.
Please explain. Please, what is the no need to explain. What is the value of lambda max value?
Two 35.
235. So this is called for exocyclic double bond. Okay, madam, no problem. So now, okay, no problem. So now we okay. This is okay. This is okay. Madam, please explain.
Yes, sir.
This
May I
value. What is this value?
Okay. Parent value, homoannular diene, 253.
Wait. Yeah, now need for this compounds.
Yes, sir.
263.
So what is the lambda max value?
Okay. 263. This is 263. 263.
2 ring residue.
Yeah. The base value is 253 and the 2 ring residue is present. Total 260 is present. Here, ma'am.
273.
Yeah.
273 plus 2 exocyclic double bond. 2 exocyclic.
So what is the value? So what is the lambda max value?
283.
Yeah. Yes, ma'am. The base value is 253 and the 4 ring residue is present and the exocyclic double bond with ring A 0, with ring A no exocyclic double bond, with ring B 2 exocyclic double bond is present. So totally 283 nanometers. So now calculate this, ma'am.
Okay. This is the head formula. $245.
245, huh? Okay, we
240.
can check. Any another faculty? So for base value, that is for 214 because this is the heteroannular dying.
239.
The 4 ring residue. So
One
4
meter.
into 5
Also.
2 exocyclic double bond.
So what is the value of this? Is 249 nanometer.
249.
So any doubt, ma'am?
Yes, sir.
249 is the correct answer.
Yes,
Any
yes,
doubts?
yes. No doubt.
Correct, sir. Correct.
So what is this?
Hmm. 253 ring residue. 273 extended.
330. 313.
303.
So we can check with the ring A, 2 exocyclic double bond is present.
Yes, 2 exocyclic double bond, 1 extended conjugation, 30.
313, sir. 313.
So with the ring B, no exocyclic double bonds. Okay. So with ring C, 1 exocyclic double bond
1
is present.
exocyclic double bond.
So what is the answer? 323 nanometers. Any doubts?
No,
No.
sir. No, sir. Clear.
Clear. Okay. So what is this? What is this lambda max value?
17.
232.
Madam?
232. 270 basic value. 3 alkyl substituents. 5 multiplied by 350.
Yeah.
Answer is 232.
Yeah, 232 is the correct answer. Base value 270 nanometers and the 3 alkyl groups 3 into 5 equal to 50. 232 is the correct answer. So what is this? So this is called
This
for
is alpha beta unsaturated ketone.
saturated ketone. So this is the different type. So alpha beta unsaturated ketone.
Carbon.
So what is the base value? 215. So this is base value is 215 nanometers.
Yes.
Don't consider this value. This is for homoannular dying. Don't consider this. We consider only for this. Ketone is present. So what is the base value? In case homoannular is present, what is the base value? 39. We can give the increment for 39. That is okay. So here, so this is the base value 215 nanometers. This side and the ketone near, don't consider for ring residue. Ketone near, we don't consider for ring residue. So keep in our mind, this is important points. So this is the starting. This is starting point. This is end point. 1 point. this ketone near ring residue or any substitute we cannot consider. Ring residue or substitute we cannot consider near for ketone sites. So now we can calculate. So this is for the alpha carbon, functional group nearest carbon, alpha carbon, beta carbon, gamma, and delta. So what is the increment? In case the alpha ring residue present for alpha position 10 and the beta position is present ring residue, that value is 12, and the gamma position is present, that value for 18. So and then delta any action, that for we can calculate for 18. Alpha 10, beta 12, and the gamma for 18. Next to delta come 18. Another one coming for 18. Keep very important point, the Woodward-Fisher rules. Only for 4 double bond. 4 double bond compound only we can consider for lambda max value. More than 4 double bond value not suitable for Woodward-Fisher rules. The Woodward-Fisher rules only consider for 4 double bonds. When the organic compound is present for 4 double bond, that is possible only for Woodward. That is obey for only for Woodward-Fisher rules. So now what is the answer this? Please calculate the answer.
Okay. $324. No, sorry. This is yes. $388. $390.
So we can check what is the answers. So what is the ring residue? So this part is for the ring residue. So another, so this is the starting point and end point. This is the starting point and this is for the end point. The blue color. So now we can check. So where how many ring residues present? So the here int is present. So we don't consider any substitute or ring residue. Keep in our mind. So and here also don't cut because they continue. So what is the value? This is for in ring B, exocyclis is present. In
Yes.
ring B, exocyclis presence. So what is the value? So nearly for 385 nanometer, madam.
390.
385.
12 ठीक है ring residue 54 so 360 exocyclic. There are two exocyclic, one exocyclic with respect to ring C.
Yes, ma'am.
So it is 390.
So, no, wait. So ring B is possible, and ring C is not possible, ma'am.
It's not possible. Why, sir? Why?
6 carbon. They are connecting 2 carbons. In ring C,
Yes.
how many carbon connected this double bond?
2 carbons.
So ring C 2 carbon connected, ma'am.
Okay, so I don't want
Only
that.
one. Understand?
No.
This double bond connect this carbon and this carbon. So this is present inside the ring. This double bond is
Oh yes, yes, yes.
present. Both side is present. C
Yes,
and B
sir.
also present.
Yes, yes, yes. Got
Cannot
it.
consider for this.
Yes, sir. Yes. So this is 385. Okay, thank you.
385 is the correct answer.
Yes, yes.
So what is this answer?
Wait. Zero three. 303.
Okay, we will check. So here, heteroaner is present. No need to calculate. No problem.
Alpha, beta, unsaturated. 200, 15, 7.
So base value 215 and the beta ring ratio 12 and the 2 higher delta ring residues, that is for 36, and the 2 extended conjugates is present 60. So here, see here.
2 exocyclic.
Yeah. Here with the ring A, so here, okay. Ring B, 2 exocyclic double bond is present.
Yes.
With the ring B. So this is for what is the value? 343 nanometer. So any doubts? Any doubts?
No, sir. No, sir.
So next, should be considered whenever chromophore is extended, act as a strong chromophore. So this is for structure of the enodes alpha. So ketone near for alpha. So this is for beta. This is for gamma. This is the delta carbons. So the acyclic 6-member enone. So acyclic 6-member enone is present. So that time 250 nanometers. In case 5-member enone is present, so what is the value? 202 nanometers. 5-member acyclic or 6-member enone is present. What is the basic value? 250 nanometers. 5-member enone is present. So what is the basic value? 202 nanometers. And extended conjugation 30, homocyclic 39, and exocyclic double bond also 5. Then for in case the ring residue same 10, 12, 18, 18. In case the presence of chlorine 15 alpha positions and beta position 12. In case presence of gamma position, that time we cannot consider, and the delta position also cannot consider. And the bromine also only consider for alpha and the beta positions. And the OH also consider alpha, beta, and the delta positions. And the ester consider for all the positions 6. The ester is the common value for 6. So now we calculate, ma'am, please this. Now we can please calculate what is the lambda max value.
Two 37.
So what is the value, ma'am?
42.
I am asking all faculty members, not only you. So what is the answers?
42.
So here the ketone is present at 6-member. So what is the answers? So this is for base value 250 nanometer, and the alpha ring residue is present. So that is for 10, and the beta ring residue also present. That is for 12. So here, so bromine is we cannot consider because bromine is not involved for any delocalizations or conjugations. Bromine is not disturbing. So that's why we cannot consider here the bromine. Bromine is present, alpha, beta, or gamma position is present. That time we can consider. Otherwise, we cannot consider for bromine positions. So what is the value? 242 nanometers.
Yes.
Any doubt, ma'am?
No, sir. No, sir.
So what is this value?
Sir, what is the increment for halogen? Bromine?
Yes, ma'am. Alpha, beta, gamma position is present. That time increment is present.
Hey, for halogen, it is different.
Halogen is where present, ma'am? Alpha position or beta position? Alpha, beta, and gamma position. Where is alpha? This is for alpha, beta, gamma position is present. So halogen is present in alpha position. Sorry, delta positions. So we cannot calculate, madam.
30, 30.
Yeah.
265.
So what is so this is for the
Is 0. Okay, gamma is 0.
so this is the answer, ma'am.
Okay. So if halogen is
270.
present in gamma, the value is 0.
0, yeah.
Okay.
So 277 nanometers. is
Yes.
present.
There is no extended conjugate. Yes, here it is. But in this
Yes.
question, there is one extended. Yeah, one
Yeah,
extended.
yes, ma'am. Yes.
Okay, okay. This is 202 basically. Three zero seven.
So the ketone is present for 5-membered ring.
Yes,
So
202.
now, yeah. So what is the answer, ma'am? 334. Any doubts?
Yes, sir. No doubts.
So what is this answer?
Two 80.
So this is for acyclic enone, ma'am.
Yes, 215 is the basic value. 217 या 215.
So 280 is the correct answer.
215. Yes, 280 is the answer, right?
Yeah. Yes. So this is for aqueous chromophore. And benzoaldehyde, ma'am, is here. This type of compound is present. C double bond OX. In case hydrogen is present, what is the base value? 250 nanometer. In case acid is present, COOH. What is the acid or ester is present? So what is the base value is 230 nanometers. In case alkyl group is present, that is phenols, that is for the 246 nanometers. So this is also important. In case aldehyde is present, So what is the value? 250 nanometers, and then 230 nanometers, and 2. Yes, madam. நாளைக்கு வரேன் madam. சரி. Thank you, madam. So the ester is as it is present 230, and the alkyl group is present, that is for 246 nanometers. So this is the increment value or alkyl group is present. So this is for the strong. Here strong pi to pi star transition is occurs here because this is act as a chromophore. The
Yes.
benzene aromatic compound act as a chromophore. So here this is for the strong pi to pi star transition is occurs. So this is the increment value, alkyl substitute. This is for the increment value. So what is the value is to R, ortho and meta and para positions. So the R is present ortho meta position. What is the increment value? 3, and the para position 10. And OH and O are present ortho and the meta position, that value for 7, and the para position, that value for 25. In case the chlorine is present ortho meta position 0, and the para position is 10, and the bromine is 2, ortho and the meta position 2, para position is equal to 15, and the amine group is 13, ortho and the meta positions, and the para position is 58. So now you can calculate, ma'am, this para amino salicylic acids. Right. So this is the correct answer, ma'am. 295 nanometers. So this is for the 295 nanometers, the correct answers. Any doubts? And more than double bonds. So and more than double bond is present. So this is no need to explain already. So more than double bonds, the Woodward-Fisher rules work well for conjugated dienes and polyenes with up to 4 double bond or less. Certain plant pigments such as carotenoids have even more than 4 conjugated double bonds. For conjugated polyenes have more than double bonds. For Fisher-Hund rules may applied in order to obtain the wavelength of maximum absorption. So here this is for Fisher-Hund rule for conjugated polyenes. So what is the formula? Fisher-Hund rule for conjugated polyenes. So what is the formula? The lambda max equal to, according to Fisher-Hund rule, the following equation can be used to solve for the wavelength of maximum absorption and also maximum absorptivity. So lambda max equal to, please this formula 114 plus 5m and plus n 48.0 minus and 1.7 n and minus 16.5 or endo, 16.5 or endo, and minus 10 for or exo. So this is for the this is the formula. More than double bond use 114 plus 5m plus n equal to 48 point n into 48.0 minus 1.7 n and 16.5 or endo and 10 or exo. So this is the, so what is the lambda max? The wavelength is maximum absorptions. What is the m? So what is the m means number of alkyl substitute or ring residue. So here what is the m meaning? Number of alkyl substitute or ring residue. So what is the n? N means number of conjugated double bonds. So what is the n? N means number of the conjugated double bonds. That is for n. And or endo. Or endo means the number of rings with endocyclic double bond in the conjugated systems. Or endo means the number of rings with endocyclic double bond in the conjugated systems. So ring inside double bond is present. That is for endocyclics. So the or exo, that is for the number of with exocyclic double bond in the conjugated systems. So what is the value? The molar absorptivity equal to 1.74 into 10 to the power of 4 into n. So this is the formula. So the molar absorptivity equal to 1.74 into 10 to the power of 4 n. So this is the formula where molar maximum absorptivity is lambda max epsilon max equal to maximum absorptivity. N is the number of conjugated double bonds. So now using this formula, so madam, please calculate these compounds. So use this formula. What is the formula? Lambda max equal to 114 plus 5m. M means alkyl substitute and n is the number of conjugated double bonds. And or endo and or exo. Endo means number of rings with endocyclic double bond in conjugated systems. Madam, any doubts?
Let us calculate first.
Yeah.
There is one doubt.
Yes, ma'am.
It is 617 is the answer. The alkyl group which are not present in conjugation, shall we count those alkyl groups also?
No, conjugation is not there.
No,
Please don't count.
We can't count. We can't count. So the value is 617.
Yeah, we can check, man. So others ready?
Yes.
So madam, this is please see this is total. How many conjugated carbon is present for nearly for
11 conjugated double
11.
bond.
Yeah.
11.
So and ring inside, that is called for endo.
One ring, two ring insides. Now one.
So
Just two.
Two endo is the presence.
16.5 multiplied.
So what is the value? Calculate this for beta carotene is here presence. So now we can check, ma'am.
Yes, substituents 6 liter. Alkyl substituent, I have written 6.
Madam, please little check. This is 17 or 1.7. Little confused. You can check. But the answer is correct. 453.30 is correct. But here you can check 1.7 or 17. I don't know. Maybe last time my student saying so that is a little mistake, sir. Maybe 17 is possible, not 1.7.
Sir, why we have multiplied 1.7 with 11?
Yeah.
So it is a common, first I subtracted 1.7 from 48, then I multiplied by n, by the number.
Yes, madam. Yes, madam. Yes.
But here you have.
No. 11 is, madam, that 11 we can, no need, ma'am. 11 is, yeah. Yes, madam. 11 you calculate, ma'am.
Why 11? 11 is common, which we have written outside the bracket.
Wait, here n. N means number of double bond.
Okay, sorry. Yes, I missed the sense. Yes. Okay, thank you, sir. Thank you. Yes, sir.
So answer is correct, ma'am.
Yes, sir. Yes.
Okay. 453.3. So max, practically what is the lambda max value observed? 452. Nearly this is calculated theoretical value, and practical value 452 nanometers, madam. And how calculate the molar absorbability? So that is this is the formula, ma'am. 1.74 into 10 to the power 4 into 11. So the n is the number of conjugate n, that is for number of conjugated double bonds. So this is for molar absorptivity 19.14 into 10 to the power of 4. This is for theoretical value, and practically absorbed 15.2 into 10 to the power of 4. Madam. This is the practical value. So any doubts?
Yes.
Madam, molar absorptivity also you can calculate. Any doubts, ma'am?
No, sir. No. Thank you. Got that.
So next, this is last final. Then we will close. So calculate this.
So, let us calculate it together.
Yeah, calculate, ma'am. No problem.
Yes, sir. Number of alkyl substituents 1, 2, 3, 4, 5, 6. Is it okay?
Yes, you can check. Madam, please, the green pots, that is for substitute pots.
Yes. 1, 2, 3, 4, 5, 6. Yes, 6. And conjugation.
And the blue color round, that is not involved for conjugation.
Yes.
Yes, sir. This is not involved for conjugation.
5, 6, 11 double bonds. N is 11.
Yeah, yes, correct. So
And-
what is this is for the answer now?
Yes.
476.309
Yes.
nanometers. That's the lambda max value. And what is the molar absorptivity? 19.14 into 10 to the power.
You can calculate it by applying the formula.
So then final I will explain. I don't know slide is here or not. Slide is not present here. Okay, no problems. So any doubt, please?
Can you share this slide with us?
Yes, ma'am. Definitely.
Very
I will.
nice PPTs. We want to teach our students like this.
Yes, definitely. I will. Yesterday, the HOD madam also was saying. I will give, ma'am. No problem. So, any doubts?
No, sir. Thank you.
Yes, ma'am.
Thank you, sir.
Any participants? Any participants have the questions?
No, ma'am. Thank you. We just revised UV visible spectroscopy today. And learned so many things.
Thank you, ma'am. Any participants write the questions in your chat box? Attendees?
I had that one question when we attached methyl group, which is electron releasing group. The value of lambda maximum was decreased and the molar absorptivity was decreased. So can you explain?
What, ma'am? Yeah, that is maybe present of electron withdrawing groups or electron donating group is present, ma'am. We can calculate electron withdrawing. A slide is there, but I am not showing that. Maybe electron withdrawing group is present. That time the molar absorptivity is decreased, ma'am. Electron withdrawing or electron donating groups.
That was electron releasing. Methyl group was there. Electron
Yeah.
releasing.
So electron donating groups, yes, ma'am.
Yes, electron releasing.
Any participants from the attendees? Can write your question on the chat box.
So, excuse me, one doubt.
Yes,
Wait.
yes, madam. Yes,
Wait,
madam.
wait.
Thank you, sir. Thank you very much.
Okay.
Thank you for the enlightening talk. I hope our audience must have been enriched in knowledge, more aware about the concept of UV spectroscopy and analytical chemistry after listening to you, sir. Thank you.
Okay, madam. Thank you very much, madam.
Thank you so much. Thank you. Sir.
Thank you very much, Venkatachalam sir.
Okay, madam. Thank you very much. madam.
Thank you very much for very wonderful, nice delivery.
Yes, madam.
All the participants fill the
No,
printed form. All the participants.
no, we have not. Is it in the chat box?
Yeah, it is in the chat box.
Okay.
Today we are not forwarding it into WhatsApp group.
Okay.
We
Wait.
want only from those who have fully attended the session.
Okay, madam. Thank you, madam.
Thank you very much, sir. We will be in touch always and
Yes, madam. Definitely.
expecting
Yes,
you offline in our campus
Yes, madam.
Yes,
Definitely.
yes,
for the
sir.
next.
Thank you,
sir.
madam.
Thank you, sir.
Thank you,
so
Professor.
much, sir.
Professor, thank you, Professor.
Yeah,
Thank you,
yeah,
Professor.
yes. Thank you, sir.
Thank you, sir.
A very nice session, sir.
Okay, madam. Okay.
Okay, ma'am.
Thank you.
Thank you, all the participants.
Yes, sir.